For this video, I'll be working through the Level 1 2018 Mechanics exam. Right. Question 1. The speed time graph shows a motion of two runners running a 100-meter race. From the graph, which runner has the greatest acceleration in the first 3 seconds? Explain your answer. Calculations are not required. So I'll pause, write the answer, and then explain. Right, so I've said runner A, their gradient is steeper, so it has a greater acceleration. They also reach 9 meters per second before runner B. So here's a graph. Runner A is a solid line, runner B is a dotted line. Runner A reaches 9 meters per second in 3 seconds. Runner B at 3 seconds is only at about 7.5 meters per second. So quite a bit slower. Right, using the graph, calculate runner A's acceleration during the first 3 seconds. So what you're going to do is look at your formula sheet, and you have acceleration is change in velocity over change in time. So A is equal to change in velocity over change in time. And the change in velocity for A is from 0 to 9. This is 9. So the 9 divided by, that looks like a 9, divided by, and it's in the first 3 seconds. Divided by 3, 9 divided by 3 is 3 meters per second, or 3 meters per second negative 2 to the power of negative 2, or 3 meters per second squared. Just what, in fact that's, yeah. Right. Using the information in the graph to compare the speed and acceleration of runner A and runner B in the first 10 seconds. I'll pause, write the answer, then discuss. Right, so what I've said is runner A accelerates for 3 meters per second for 3 seconds, up to 9 meters per second, and you can see that here. Runner A starts at 0, gets to 9 meters per second, does it in 3 seconds, and then it remains at 10 meters per second, so a constant speed, up until 10 seconds. It's only asked up until 10 seconds. We're only going to give up until 10 seconds. Runner B accelerates at, I calculated there, 10 divided by 4 equals 2.5 meters per second. The reason being is it gets up to 10 meters per second, and it gets there, runner B, the dotted line, I should say. The dotted line gets there in 4 seconds. So 10 divided by 4, 2.5 seconds. And stays at this speed for the next 7 seconds. And that's really all you need to put. That's the difference. Right, use the information in the graph and calculations to show which runner A or B finishes the 100 meters first. Right, so I'm going to go distance of A, and that is going to be equal to, right, so we're going to, so this is a speed time graph. So the distance is literally the area underneath the line. So in this case we're going to do runner A first. So we're going to split this up. Let's do some solid lines actually. That's a solid line. We're going to split this up into one shaded area. This is for runner A. I'm not going to try and do it for, I'll do it for runner B, but I'm not going to shade it in. That's shaded area 1. I hope you can see that. And now I'm going to shade in this area here. So it's actually everything under this graph. So it's all of this area here. All of that is for runner A, that whole area. So I'm actually going to do it a bit trickily, a bit different to the answers, or I think that's how they do it. I'm not even sure. I have to check. I'm going to split this. This is going to be one triangle, this is going to be one big square, and this is going to be another little triangle here. So so 2 little cubes is 1 second, and 2 little cubes here is 1 meter per second. Right, so back over the page, the first triangle is, for A anyway, is 3 across, and 9 up, but it's a triangle, so the area of a triangle is half. It's half base times height. So we're going to go half, and then the base was 3 times the height was 9, and now we're going to add the square, and the square is from 3 to 12, and it goes up to 9. So it's a 9 by 9 square plus 9 by 9 plus, in our last little triangle, this little triangle here, this one here, I'll just shade it a little bit, is 2 by 2 square. So it's going to be plus, that's a triangle, because you can see it sort of goes up in a vertical bit, plus 2 times 2. And if we do this, we get 13.5 plus 81 plus 2, which should give us 96.5 meters. Right, distance B. Distance B. Same again. We have B goes up to 10 and it takes 4 seconds. So here's our other triangle. I'll just make it really messy and draw over it. This is our other triangle. I'll draw it even darker. And it's from 0 to 4 and 4 to 10. So the base is 4. So we're going to go, that's a triangle as well, half our base, which is 4, times our height, 10, plus, same trick with that cubey bit, but we're going to go, the cube is from this cube here, from 4, because this is where it starts, up here, 4 till 12. So 4 till 12, the difference between those two numbers is 8, because 12 minus 4 is 8. So we have a base of 8 and a height of 10. So it's going to be, so we're going to have 8 by 10. So we're going to be half, base was 8, height was 10. And we have one last little triangle, 2 down the bottom, 2 up top. So it's a 2 by 2 triangle, because this is a square. Oh, this is not half, because that's a square. That one there is a square. This from down here across up there. That's a square. So it's not going to be half there. Plus a half, a 2 by 2 triangle. And that is going to give me 20 plus 80 plus 2 is going to give me equal to 102 meters. So we're going to answer the question. Runner B, runner B finishes first. F-I-R-S-T. Right. What do we got? Each of runner A's feet has a surface area of 0.02 meters, which sink into the track. Together, the feet exert a pressure of 13,000 pascals. Calculate the weight of runner A. So weight is a force. Let's check an F there. This is a pressure, P, and this is an area, A. Calculate the weight of runner A. So, in your formula sheet over the page, you'll have, where is it? Pressure equals force over area. So I'm going to write that down. Pressure equals force, all right, divided by area. Some of you guys might be used to the whole triangle method. Oh, I don't teach this in here. I don't even teach year 11, so I don't know. I'll rearrange this algebraically and then I'll try and figure out how it's going to work on the old school method. It's been a while since I've done that. Right, so opposite of divide is multiplication. I want to isolate F, so opposite of division is multiplication. So I'm going to have pressure times area is equal to the force. Okay, there you go. So this would be the force up top, this would be pressure, and this would be area if you were to draw those stupid triangles. These are bad. Don't learn how to use this. Otherwise, maybe learn a little bit how to use this, but learn how to do algebra if you want to continue with physics. Right, so that is equal to, what is the pressure? The total. So now we're going to be careful. This is probably going to throw, this will be like a tricky question without throwing something stupid in there. Feet. I'm guessing that just means 1 foot. So 2 feet would be 2 times the area. Just reading into it. So I assume that would be the case. So that is going to be 13,000 times bracket 2 times the area, which is 0.02. You've got to use meters squared. You can't use centimeters squared. I don't know what. They probably just gave you to throw you off. And that'll equal, what is that, 520 newtons. Just remember, yep, it's a force, weight's a force, cool beans.